Have you ever wondered how to do proper global exception handling in a C# web API? Let's start by sketching a real-world scenario. There are two teams actively developing a web application. One team on the front end and one team on the back end. While developing, the front end often sends HTTP requests to the backend API to register a new user and to authenticate that user with the backend. Every now and then, the front end receives a 500 internal server error back. So they tap the backend team on the shoulder and ask for either a fix or an explanation. Did they misspell something? Or is it a problem in the backend project? An internal server error with a stack trace of the backend might not tell the front-end team enough. So let's tackle that problem with declarative customized exceptions and global exception handling on the web API. I scaffolded a new .NET web API and added a line that conditionally throws an exception. The result you see in the Swagger, it's a internal server error with the stack trace. That's just saying where on what line the error happened, but not much details about what exactly happened. No details about the conditional that threw the error, for example. If we take a look at the backend code, you can see the conditional throwing an exception. The good thing about this is the API did not crash. The app didn't stop. I can still send requests that do succeed. So that means that there is already some built-in exception handling happening on this .NET Web API. Because by default, most exceptions are translated into an HTTP response with the status code of 500, which means internal server error. That's the default out-of-the-box behavior of a .NET Web API. So a couple of things. This is actually more like a validation error. So the front end passed incorrect data to the backend, or at least data we don't want. And then it exposes the entire stack trace, which is generally not a good idea. This might contain sensitive information about your backend, and it's not useful to the front end to know at which line it happened and so on. Another thing that's not great is we don't want to be returning a 500 for any possible exception, since that's not really specific. So in this case, we're getting a validation error, like the front end is sending a request that we don't want to accept, so it would be more appropriate to then return a 400 bad request. We could alter this code to return a bad request with an error message, and that would result in a nicer output. More specific, 400 bad request and the reason. But now we lost our exception details, and this bad request is a part of the controller base. So we can't simply reuse that, for example, in another class library if we move the business logic out to another place, or even in a service class in the same project. We'd have to drag that dependency of ASP.NET Core MVC in here, and then all our return types should resemble the action result. That's not a great approach, so we'd want to still throw an exception, but translate that into a nicer output to the consumer. So if we now throw an exception and then catch it in the controller, we could return a bad request, log the error, and pass the exception message to the consumer. So that's what we're going to do, but of course we're not going to try catch everything ourselves and then translate every exception to the fitting result. We're going to take a more global approach using the exception filter of the .NET Web API. Let's start by creating some reusable, more declarative exceptions. You can simply make a new class, give it a declarative name, and inherit from exception. Now we could throw a forbidden access exception, but we can't pass anything, since this is the very simple implementation. Running this code with the try catch still in place, we get an exception of type, then the class we just made was thrown. This doesn't tell us much more than the general exception class we used before, because this thing doesn't really do anything but inherit from the exception class. But the reason we're giving it a specific type, a specific name, is to later on in the global exception handler to, depending on the type of the exception class, we'll want to return a different result. For example, for this forbidden access exception, we'll want to return a 403 status code. For a unauthorized exception, we'd want to return a 401. For a not found exception, we'd want to return a 404, and so on. Let's take a look at another exception class I just made. I inherit from the exception, and there's a few constructors and overloads. So we can overload the constructor with parameters, which will then be more details, which will then be passed and shown in the result. So that's how you make custom exceptions. Of course, you could make way more specific custom exceptions, for example, user not found, or whatever you want. And you can customize those keys and names however you like. Maybe you just want to have like a specific message, user not found, for example. That's up to you. I've seen scenarios where the front end wanted really specific types, and I've seen scenarios where a 3 to 5 custom exception classes were enough to get the message. So then we could use it, throw new not found exception with a key of the property that caused the exception, and then the value of that property. And then we see that we pass a message of entity name key was not found. So that's what we're going to see in the result. Entity date, it's not an entity, it's a property, but you get the idea of customizing it. And then the value, then instead of not found, you could say is not 24 hours in the future. I think you understand what I'm trying to convey. So in case of the user not found example, you could pass as key user. So what didn't we find? The user. And then as value, maybe the user ID of the user name or the email address. And in that way, both the front end or the back end can act upon this exception message. That is a bit more detailed than before. So that's all I wanted to say about making your own custom exceptions. And we're just going to undo this try catch. And let's start building that global exception handler. By global, I mean we'll want this exception handling behavior consistently over all of the controllers and all of their methods endpoints. So we'll build an exception filter and apply that globally to handle exceptions that occur before the response body has been written to. So middleware is some code that executes on the request cycle. So it could happen before the request comes into the controller method or before the response goes out. A filter is similar, only it happens on the MVC pipeline, the MVC cycle. There are different types of filters, as you can see on the documentation page. Each of these will execute in a fixed order. So the authorization first, then we can see this below. So first the middleware, then the authorization filter, resource filter, exception filter, action filter, right before the action executes, so the controller method. Then afterwards you can also execute some code. The result filter, that would be when the the response returns, so the OK response or the no content result, these types of action results. Okay, that's enough of me trying to explain the ASP.NET Core framework. So I built a API exception filter attribute. If we click through on the exception filter attribute, it inherits the attribute and the exception filter. The exception filter will then provide us with overwritable methods. On exception async, on exception. We just have to use override one of these, but let's not dive in too deep. And it's an attribute, so we could apply that to a specific controller or a specific controller method, or in our case we want to apply it globally, so we'll want to have it on all our controllers and on all our controller methods to be consistent. So let's go over the code. We created a dictionary and then fill that up and initialize that in the constructor of this class. And it's a dictionary where the keys are the name of the exception. So it could be our custom exception, like the not found exception and the forbidden access exception, or it could be the unauthorized exception, for example, coming from let's have a look. System exception. Let's not dive in too deep. And then a method as the value, which the method we want to invoke whenever an exception occurs with this name type. Sorry. So then we overwrite the onException that we just saw. A method handle exception and pass the context. By the way, this is code that can be found in Jason Taylor's clean architecture template, and you'll most likely also find this code in all of my templates regarding full stack development or backend development. I just slightly modified it to my use case. So then we get the exception type and see if our dictionary contains this type, and if it does, we invoke that method that was passed as the value. Then we just do that. If it's model invalid state, then we execute another method which then translates that exception into a bad request object. So this is basically a validation exception, and then we return it to the user, to the consumer as a bad request. nicely formatted with the details. We'll run that in a bit. Of course, then we still have all of these methods which do something similar. Translate that exception into a more detailed result that is more specific to what happened. So the not found object result with the details specified above. And that's a way to translate an exception into a proper result without losing the exception details and while being declarative and explicit, and without having to return these result objects yourself all over your code base. So that's neat. Then there's one for the unauthorized exception, which will return a unauthorized status code. The forbidden will return a forbidden status code with details always, of course. And then, so we're now handling the most common exceptions, the exceptions we expect to happen. If you would like to handle another type of exception, for example, the DB concurrency exception or a conflict exception, you can just add this to the dictionary, for example, type of DB concurrency exception, and then make a method handle concurrency exception, and then maybe the status code you could set to 429 conflict. That's how you would go about that. Then let's go back to this handle unknown exception. I commented that out because I experienced that it was swallowing critical errors, like my bad configuration of AutoMapper or some database errors. At this moment, I don't have proper logging in place to log that stack trace and to alert me of that critical error. So until I have that, I will leave this commented out. You can take a look at Jason Taylor's clean architecture template. Mr. Taylor handles that with an unexpected exception behavior, if I'm not mistaken, which will give a proper log error of the actual critical exception. And if that is in place and properly working, you can comment this out without risking to lose your stack trace details or not knowing what's going on. That's all good and well. That's now we have this attribute, but it's still not going to be applied on our controller since we haven't used the attribute. So we could just simply add this attribute at the top of every controller, but that's not what we want to do. So that would be API exception filter. But that's not what we want to do. We want to go to the program and add that as a global configuration. Simply say options.filters.add and our custom API exception filter attribute. If we now restart the application, the web API, and we trigger that same endpoint that throws an exception, a not found exception, then we get a nicely formatted result that translated the exception. So with the status of 404, not found, specified resource was not found, that's the message. That's specified in the API exception filter. And then the detail is our custom message of the not found exception along with the parameters we passed to the not found exception constructor. So I showed you how to create your own custom exceptions that are fully under your control. And instead of manually having to try catch all possible exceptions and attempting to translate those into your own object results, we now have this global API filter in place that can anticipate our custom exceptions or the system exceptions and format these properly and consistently. So you no longer have to return your own error results. And in the next video, we'll implement validation with fluent validation, so we don't have to write 50 lines of if-else if statements to check whether the request data is valid. And once we have proper validation, we'll make sure our API exception filter can translate those custom validation exceptions into a bad request object result. I hope you got wiser from this video. If you did, please leave a like. I'm halfway to 100 videos, so subscribe to stay well informed.